Thanks, James. We all know that we're living in a non-stationary climate. Global warming is already altering climate and extremes, including flooding, and this will continue to worsen in the future unless strong global climate action is taken. And because of this kind of future risk of climate change, we provide a range of different climate options with our products. Next slide, please. So at Fathom, we've developed climate dynamics, which takes future changes in extreme rainfall, river discharge, and sea level, and incorporates the impacts into our flood and catastrophe models. And this tool allows the assessment of flood risks for any subperil, any plausible climate scenario anywhere in the world with uncertainty. And climate scenarios can be based on a year, combined with either a global warming level between 1 and 5 degrees C compared to the pre-industrial period, or an emissions scenario such as the SSP, RCP, or NGFS scenarios. And so uncertainty in the projection is represented in the form of percentiles. Next slide, please. So this plot shows the range of emissions scenarios that we can provide at Fathom. So we have time to the end of the century on the x-axis and global warming level on the y-axis in degrees C. And so this is the change in global average temperature relative to the pre-industrial era. And you can see that there's a few different sets of scenarios that we can provide. So the SSPs, RCPs, and NGFS scenarios are shown by different line types. So whether there's a dash, a dot, or a solid line. And then within each of those sets, there are a number of different individual emission scenarios, which are shown by different colours. And these range from scenarios with relatively low greenhouse gas emissions and warming of around sort of 1.3 degrees C, up to scenarios with high emissions and high warming levels approaching 5 degrees C. And I'm going to talk about these different sets of scenarios in the next few slides. But just to note, we can also provide scenarios based on global warming levels. So if you're interested in a kind of Paris Agreement style scenario of 1.5 or 2 degrees C, for example, then that is also available. Next slide, please. So this slide shows the products that our climate dynamics is available in. We have our flood maps, so it's available in the global flood map and the US flood map. We also have a slightly different version of climate dynamics in the UK and the Japan flood maps, which include a more limited set of scenarios, and these are based on regional climate model data rather than global climate model data. But the full climate dynamics for these countries is available through the global flood maps as well. Our risk scores are a simple but kind of powerful set of flood risk metrics. These were developed as part of our global flood map, and they allow users to really easily compare the flood risk for assets across a portfolio under different climate futures. And finally, our global flood cap model with climate dynamics was launched last month, as James just mentioned. And this allows users to quantify the impact of climate change on flood hazard and also potential losses. Next slide, please. So a common question we get, as you might imagine, is which scenarios should you choose? Because there are obviously lots of different versions. And there isn't really a right answer on this. It somewhat depends on what your use case is, how far into the future you're interested in, what your view of risk is, amongst other things. The main thing we would recommend is to consider more than one scenario, since we don't know how future greenhouse gas emissions and associated warming will evolve. But during this webinar, we're going to give a bit more information and guidance on the different scenarios that we can provide. So hopefully it will provide a bit of clarity to you. So for example, if you're performing a standard risk assessment or scenario analysis, you may choose to select scenarios from the broadest set that we provide, which underlies several of the other sets anyway, and these are the SSP scenarios. Next slide, please. So SSP stands for Shared Socioeconomic Pathways, and these are IPCC scenarios, so that from the Intergovernmental Panel on Climate Change, and they were used in the latest assessment report, the sixth assessment report. And these were essentially developed by climate scientists and economists and energy systems modelers to examine how global society and demographics and economics and energy systems might change over the next century. And there are 5 SSPs in total, which you can see, well, 4 of them anyway, the 4 main ones on the left-hand side. And these all make different assumptions about those things that I mentioned. And then within each of these, there's a number of different scenarios that kind of fall within them. But there's 5 key scenarios that are generally used, and these are the ones that are shown on the plot on the right-hand side, along with historical observations of global warming. And these scenarios range from projections with lower warming, which is shown in blue. So these assume a more sustainable future and are associated with low challenges to mitigation and adaptation. There's the more sort of middle of the road scenario shown in yellow, with more medium warming and medium challenges to mitigation and adaptation. And then there are the high emissions scenarios with high warming, which are shown in red. And these are associated with high challenges to mitigation and adaptation. I also mentioned the RCP scenarios a couple of slides back. So these are the representative concentration pathways. And these are the previous iteration of these SSP scenarios. So they were used in the fifth IPCC assessment report. And they're broadly similar to several of the SSPs, although with some differences in kind of the evolution of warming over the next few decades. Next slide, please. So as an example of another use case, financial institutions are increasingly being put under pressure by regulators and investors and consumers and other stakeholders to identify and assess and mitigate the possible risks arising from climate change. So if you're responding to regulation, for example, carrying out climate stress testing, then it's likely that the regulator will have specified which scenarios you should be considering. Next slide, please. So one examples of scenarios that can be used for climate stress testing are the NGFS scenarios, which were developed by the Network of Central Banks and Supervisors for Greening the Financial Systems. That's what NGFS stands for. And these are a set of scenarios that have been adapted from the IPCC scenarios, which aim to provide a current and up-to-date reference point for understanding how climate change or physical risk and climate policy and technology trends known as transition risk could evolve in future climates. And they aim to essentially help central banks and supervisors explore possible climate impacts on the economy and the financial system. So at one end of the spectrum on this plot, you can see we've got physical risk low to high on the bottom x-axis, and then transition risk low to high on the y. So at one end of the spectrum, we have the orderly scenarios, as they're known. So these assume that climate policies are introduced early and become gradually more stringent, and this results in relatively low physical and transition risks. And then at the other end are the scenarios where no additional action beyond current policies are taken, or it's taken too late to halt significant global warming. And these scenarios result in severe physical risk, including some irreversible impacts. Next slide, please. So another example of regulatory requirements include the Climate Biennial Exploratory Scenarios, or CBES, which was the name of the Bank of England's first exploratory scenario exercise on climate risk carried out in 2021. And the CBES scenarios build on the NGFS ones and define a set of years and associated warming levels that these banks and financial institutions were asked to assess risks for. And as part of CBES, the UK's largest banks, life and general insurers and Lloyd's syndicates were required to assess the impacts of physical and transition risks of climate change. Another example is the EU taxonomy. So this is a classification system which establishes a list of environmentally sustainable economic activities which financial institutions are encouraged to align their portfolios with. And it includes criteria for mitigating flood risks, such as investing in flood defences and sustainable water management systems as well. Next slide, please. When you're picking scenarios, you might also decide to take into account some of the latest scientific research. For example, by selecting scenarios based on which are thought to be more or less plausible, depending on current climate policies that have been or may be implemented. Next slide, please. So this plot shows warming projections based on current policies and commitments compared to the full AR6 SSP range of warming projections. So again, we have time on the x-axis and global warming level on the y-axis. And under current policies, climate models suggest a median future warming of 2.7 degrees C in 2100, with a 5th to a 95th percentile range of 2.3 to 3 degrees C. So this is represented by that kind of orangey colour bar. It should also be noted that current policies represent something of a moving target. Obviously, like policies and technology does change through time, so these projections will vary as time goes on. But broadly, this is where they were, I think, in 2021, I think the study is based on. Projections based on climate action commitments are also shown. So you can see the yellow bar shows the 2030 nationally determined contribution commitments, and then net zero commitments are shown in blue. And you can see that they show lower levels of warming at the end of the century than current policies, because they assume additional action on climate change. But you can see that the range of warming covered by these three kind of sets of projections cover approximately half of that of the full range of IPCC AR6 warming, so those SSP scenarios. And most of the reduction is seen at the high end of the warming range, but there is some reduction in the lower range of warming as well. Next slide, please. So there's therefore been a little bit of a move away from these very high-end emission scenarios in the scientific literature. And this is partly because these scenarios assume that current and future energy production is dominated by coal, whilst in reality, the world is generally transitioning away from continuing fossil fuel expansion. The latest IPCC AR6 report stated that high-end scenarios have become considerably less likely, but cannot be ruled out. So the sort of SSP 5.8.5 and to some extent SSP 3 7.0 worlds would require the active reversal of past progress. So the kind of currently implemented policies would have to be reversed. And so it's thought that that's generally quite unlikely. So their main use now is thought to be sort of high-end, high-risk scenarios. And estimates of future emissions and future warming under current policies tend to most closely match the sort of middle of the road SSP scenario, so SSP 2 4.5. And you can see on this plot that's sort of 2.5 to 3 degree warming based on current policies is thought to be sort of the most likely at the minute. But as stated, the kind of high-end scenarios can't entirely be ruled out, even if they are thought to be less plausible. And there are other uncertainties in the sensitivity of the climate system to greenhouse gas emissions, which do mean that they may still be useful if it turns out that the climate system is more sensitive and has higher warming to greenhouse gas emissions than our climate models predict or than we might have thought. The paper that is shown on this plot in this slide as well also did a survey of IPCC or some IPCC authors and concluded that there's also skepticism among these authors that even that central 2.7 degrees C estimate of current policy outcomes will be achieved. So apparently more than half of the authors that were surveyed expected at least a 50% chance of reaching or exceeding 3 degrees C by or before 2100. So there is still a potential use for some of those sort of higher warming scenarios, particularly if you've got a more conservative view of risk and want to kind of look at the not worst case scenario, but the kind of real extremes in what those changes could be. Next slide, please. So as I said, which scenarios you should choose, it really depends on your use case, how far into the future you're interested in and what your view of risk is. But hopefully that's provided some helpful context and some helpful information about the different scenarios that we have available and which may be most suitable for your use case. As you can see from the plot, many of them are loosely paired across the different sets. So SSP 5.8.5 and RCP 8.5 are very similar, for example. So they show similar trajectories and end of century levels of warming. But yeah, as I mentioned, standard practice is to go for 2 or more scenarios, including a sort of lower and a higher warming scenario, just to account for some of those uncertainties in future developments and emissions, to make sure you're kind of covering the high end of risk and then the lower, more optimistic end of what the risks might be. Next slide, please. Any questions? I think is what we will move on to next. So yeah, if anyone has any questions, please put them in the Q&A box. If anyone would like any more information on climate dynamics and how it was made, and also how it's integrated into the global CAP model, then there are some links on these slides. And obviously, we're always happy to talk about climate scenarios. So if you are struggling to decide which ones to use, then absolutely get in touch and we can have a bit of a discussion about it.